Something spooky is happening at the edge of our solar system. You must be wondering what is happening in the haunting depths of the solar system. Let's dive into that and find out. NASA's Voyager 1 is on a fraught and unknowable journey into deep space. Some 14.6 billion miles from Earth, it and its sister craft, Voyager 2, are the furthest human-made objects from our planet. Having made it beyond the edges of our solar system and out into the interstellar medium. At such distances, anything can go wrong. Add to that the fact that these are old craft. The Voyagers launched in the 1970s. So when Voyager 1 started to send home weird, garbled nonsense instead of telemetry data in May of this year, NASA engineers might have been forgiven for calling it a day and pouring one out for perhaps the most successful space mission of all time. But that's not how NASA works. Instead, they started working on a remote diagnosis and fix for the record-breaking spacecraft. Now, some 4 months later, they are triumphant. Voyager 1 is back online and communicating perfectly with ground control as if it never happened. In fact, the fix turned out to be relatively simple, or as simple as anything can be with a 22-hour communications lag in each direction and billions of miles of space in between. NASA's Voyager 1, the farthest spacecraft from Earth, said farewell to the solar system almost a decade ago, passing through an invisible door some billion miles from Earth and crossing into interstellar space. Since then, it's stacked on another 3 billion miles and it's still sending home data, allowing scientists to probe the space between stars. In a paper published in the journal Nature Astronomy, researchers examined data beamed back by Voyager 1's plasma wave system over its journey, but particularly after it passed through over the solar system's border. The border is a messy edge where the sun's influence disappears and the interstellar medium begins. The medium is typically characterized as empty, desolate, and dark. But the PWS on Voyager 1 has detected a low, constant patterning against its detector. Space raindrops gently falling on a window. Those drops signify plasma waves or interstellar gas, and is constant company for the spacecraft. Voyager 1's plasma wave system detected a shift in the gases once it crossed the heliopause. Between bouts of strong solar eruptions caused by the sun, there was this continuous hum, a signature sound of interstellar gases. "We're detecting the faint, persistent hum of interstellar gas," said Stella Coach Ocker, a doctoral student at Cornell University who led the research. "It's very faint and monotone because it is in a narrow frequency bandwidth." For almost 1 billion miles, Voyager 1 could hear the monotone drone, and the researchers believe these weak plasma waves are distinct from other detections made in the vast nothingness of interstellar space. For instance, sometimes the sun gets cranky and erupts, spitting particles out into space. The outbursts have a characteristic signature that James Cordes, an astronomer at Cornell, likens to a lightning burst. "The interstellar medium is like a quiet or gentle rain," said senior author James Cordes from the George Feldstein Professor of Astronomy in a statement. "In the case of a solar outburst, it's like detecting a lightning burst in a thunderstorm and then it's back to a gentle rain." Those bursts were once used to determine the density of interstellar plasma. But this low, constant hum shows Voyager is collecting plenty of information without the solar outbursts. "Now we know we don't need a fortuitous event related to the sun to measure interstellar plasma," said Shami Chatterjee, a research scientist at Cornell and co-author on the paper. Future missions to interstellar space would help clarify what's happening out there, and NASA has plans for such a mission. feasibly in the 2030s. Voyager 1 has a sister probe, Voyager 2, which is traveling out of the solar system in a different direction. In 2020, while upgrades were being made to one of the Deep Space Network's communication dishes, Voyager 2 wandered space alone. In November, we pinged the spacecraft for the first time in 8 months, and fortunately, it pinged back a hello. The pair was launched in August and September 1977 and have been zipping away from Earth ever since. Voyager 2 left the solar system in 2018 at a completely different point to Voyager 1. The crossing enabled researchers to further probe the heliosphere, the giant protective bubble of solar wind that encapsulates the solar system. The Allen Telescope Array in California is still receiving signals from the Voyager 1 probe, despite the fact that NASA launched it 45 years ago. And at the same time, it is still currently speeding toward the outer edges of the solar system, way beyond the orbit of Pluto. The Allen Telescope Array, or ATA, a recently refurbished radio observatory near San Francisco in California that is dedicated to the search for extraterrestrial life, made contact with the Voyager 1 probe on July 9 using its 20 of its 42 dish antennas, which are over 20 feet or 6.1 meters wide. The telescope recorded 15 minutes of data, according to a statement which were stored on a disk. The detection of Voyager 1, the farthest human-made object with the refurbished Allen Telescope Array, is an excellent display of the telescope's capabilities and strengths, and a representation of the outstanding hard work put by the ATA team since the start of refurbishment program in 2019, the team said in a statement. The statement didn't provide any additional information about the signal it got. NASA has been investigating a strange glitch that has caused Voyager 1 to send back nonsense data about its location in space. NASA first reported the glitch in May, although it has not specified when the issue began. The agency is confident the spacecraft is safe because if the gibberish data were accurate, the signal from Voyager 1 wouldn't be properly pointed toward Earth. Currently located about 14.5 billion miles or 23.3 billion kilometers away from Earth, 156 times the Sun-Earth distance, Voyager 1 is still being tracked by NASA's Deep Space Network, sending a meager 160 bits per second of data back home. For comparison, a regular home broadband connection is measured in megabits per second. That is, millions of bits per second. Voyager 1 still has to fly through the Oort cloud, a spherical disk of comets and asteroids at the farthest reaches of the solar system, more than 2,000 Sun-Earth distances away from the Sun. No spacecraft has ever visited the Oort cloud, and Voyager 1 will take about 300 years to get there. By then, however, the probe will be long dead as it's expected to run out of fuel to power its systems as early as 2025. Voyager 2 now has 5 remaining functioning instruments, and Voyager 1 has 4. All are powered by a device that converts heat from the radioactive decay of plutonium into electricity. But the power output is decreasing by about 4 watts a year, and NASA has been forced into triage mode. 2 years ago, the mission's engineers turned off the heater for the cosmic ray detector, which had been crucial in determining the heliopause transit. Everyone expected the instrument to die. The temperature dropped like 60 or 70 degrees Celsius, well outside any tested operating limits, Spilger says, and the instrument kept working. It was incredible. The last 2 Voyager instruments to turn off will probably the magnetometer and the plasma science instrument. They are contained in the body of the spacecraft, where they are warmed by heat emitted from computers. The other instruments are suspended on a 43-foot-long fiberglass boom, and so when you turn the heaters off, Dodd says, those instruments get very, very cold. How much longer might the Voyagers last? If everything goes very well, maybe we can get the missions extended into the 2030s, Spilker says. It just depends on the power. That's the limiting point. Even after the Voyagers are completely muted, their journeys will continue. In another 16,700 years, Voyager 1 will pass our nearest neighboring star, Proxima Centauri, followed 3,600 years later by Voyager 2. Then they will continue to circle the galaxy for millions of years. They will be still out there, more or less intact, aeons after our sun collapsed and the heliosphere is no more, not to mention one pale blue dot. At some point in their travels, they may manage to convey a final message. It won't be transmitted by radio, and if it's received, the recipients won't be human.